Welcome back. In this lecture, we will start with Module 7. Module 7 is trip generation and distribution, and in lecture 31, we will start with travel demand forecasting and trip generation. The different concepts that will be covered in this lecture are on travel demand forecasting, advanced travel demand forecasting, trip generation, trip rate analysis, and cross classification analysis. So, travel demand forecasting or the purpose of travel demand forecasting or prediction of travel demand is to evaluate the effect of various options or alternative scenarios, including the business as usual scenario. So, that means we need to understand that how people travel or take their travel decisions, like what mode they choose, when they travel, where they travel, all these decisions has an outcome which needs to be determined, and it needs to be determined for the business as usual scenario, that everything remaining same, what kind of travel demand would be happening maybe 5 years down the line or maybe 2 years down the line. And at the same time, if certain things changes, that means there are some, for alternative scenarios, we also need to evaluate how the passenger travel demand will change. So, in this way we can always evaluate some new scenarios which probably where we will try to improve upon certain we will have certain objectives, like to reduce the total vehicle kilometers traveled, or it could be reducing total emissions. So, we can take several have several objectives, and accordingly we can also develop some alternative scenarios as well. So, passenger and vehicle demand between all relevant pairs of origins and destinations are estimated, and we try to incorporate behavioral principles while estimating this passenger and vehicle demand. That means behavioral principles means what are the different ways people changes their choices as per different their characteristics, as per certain perceptions and so on. So, these are the different behavioral principles that will be also investigated, also looked into in travel demand management. And then we try to also determine that how sensitive will be the policies and options that we are trying to implement. Like, for example, what will be the effect of odd even policy on a particular city, like odd even policy for allowing vehicles to drive on very polluted days. So, we have seen, so what would be the effect of that policy. So, all these things needs to be evaluated in the context of a city, and that is where travel demand forecasting comes into play. The only thing is, whatever models that we develop within this travel demand forecasting frameworks, all of them needs to be validated, and we need to also recalibrate them at certain intervals, so that these models remains relevant for that time period. Because sometimes we will see that certain things are changing in the society, or certain things are certain choices are becoming available. So, that actually shows that means the way people takes decision changes, even though the basic basic characteristics that influence the decision may remain same, but their relative effects may change. So, that is why we need to have frequent recalibrations of these models. So, that frequent means maybe at the end of every 5 years, or at the end of even in some people do it at the end of every couple of years. So, that is that kind of recalibration is also required. So, the predictions depend on target year land use, building use and density, target year population and their distribution, and the target year modal alternatives. So, we are doing our models based on existing situation, existing data sets, existing present year all the characteristics, but using this we are going to predict for target year land use, building use, population, distribution, or modal alternatives that would be evaluated in future. So, or which will be available in future. So, these are the ones which we will consider while we develop our models. So, this is the sequential 4-step travel demand model. So, you can see in this particular model, we start with socioeconomic and characteristics of the households, and we also start with the number of households and the number of employments in different zones and all, and then from there that data is used to develop the number of trips which are generated or the number of trips that are produced and attracted in different zones. And once we have done that, we develop our trip distribution, which actually helps us to understand how many trips travel from one area to another area or one zone to another zone. And this could be happening in both ways, like we can start with one zone and go to another zone, and again in the evening we will return from that other zone to the first zone. So, this the origins and destinations actually are interchanges during the different trips. So, we say that number of trips produced by a zone, number of trips attracted by a zone. So, when we do this trip distribution, we also require data from the networks, like for example, we have the highway network or the transit network or the road network. So, what are the travel time along those particular links that is required to develop the trip distribution model, where the distance between different zones plays a big role, along with the total number of trips that are generated and attracted on those zones to predict total number of trips that would be distributed among different zones. So, once we know the trip distribution, the next choice is to determine the mode choice. The next step is to determine the mode choice. Now, mode choice is very tricky in the sense mode choice may depend on certain things. For example, it may depend on the time of the day, and it may also depend on what kind of not only on the time of the day, which destination we are going to. So, it may depend on that, because trip of course, we are doing for every I to j zone the number of trips we are dividing we are determining the mode choice. So, automatically it is like as per the destination we are doing the mode choice. So, the next we primarily want to do it for the which time of the day. It could be for peak hour, non-peak hour, or it could be for every hour we can determine what is going to be the mode choice in that particular zone to zone movement. And once we do that, we can either have people going into cars or two-wheelers or to transit, public transit, and then a public transit again could be of different types, like it could be rail, it could be bus, and so on. So, as per that, this goes in two directions. One is towards the transit network and the other is towards the highway or the road network. So, when it goes from the highway network, automatically we need some input from the highway network to, that means the travel time taken by different modes actually influences the mode choice. Similarly, over here the travel time taken by different transits influences the mode choice, and the travel time taken by transit also influences the trip distribution by transit. So, that actually overall trip distribution. So, that means there are some feedback loops that go back to the initial model. So, that means it's a estimate which is done in a number of iterations. So, once we have done our model, we have executed our model, we have got some amount of mode choices, and like car could be again for auto occupancy of single person in one car or multiple people going in one car. So, carpooling. So, there we can have mode choice for single occupancy car, drive alone, or drive or a shared ride with one passenger, shared ride with two passengers. In that way, we can also expand the car choices, and it could be and we will take input from the highway travel times as well. Once we do that, then we have to assign these trips to a particular highway segment. That means highway segment could be composed of many links. So, we will assign these trips as per that time of the day at a particular highway segment or a particular route, which will include many links, and we will do that for every TIJ, every zonal movement, like from every interzonal movement, and that actually that means in some links there will be people moving from different zones to different zones. So, this will be all added up, and this process is called the assignment process. So, there is a different assignment process for transit and a different assignment process for highway. And when this happens, that means the more number of cars are assigned to a particular route or a particular link, the travel times will be affected, and that changes the travel time. And as you can see, and this actually leads to change in the trip generation. It actually leads to which comes over here, then it leads to change in trip distribution, and it also leads to change in mode choice. So, these are the feedback loops that is there in the model. So, usually this iterations takes place several times, and then when everything is more or less stable, nothing much is changing, then we stop estimating the model and we give the travel demand assessment for that particular city. Now, in most cases, people only develop a peak hour model. That means, once they have determined their trip distribution and their mode choice, they will only select the peak hour time period and then determine that how many vehicles or would be moving during that peak hour, and all the capacities of highways or transit are determined based on that peak hour model. Because we understand at the peak hour the network is highly stressed, the most highly stressed, and that is when, if we determine the capacities and all, then it is going to be adequate for the other times of the day. But problem is, we don't need only to assess the capacity of the highway or the transit network, we need to also understand the distribution of travel demand during the entire day, because there are several modes which depend on that. We will come to those things, and certain choices of modes and destinations are dependent on what time of the day. So, that actually plays a big role, and that is why a full day model is required, and we can divide the entire day into some time periods, or it could be every hour, and accordingly we can do the prediction for trip distribution and eventually mode choice, and then highway and transit assignment. So, this is the sequential 4-step travel demand model. So, in advanced travel demand models, where we have to look beyond the peak hour. Like I say, the basic travel demand models, we only look into the peak hour model, whereas in a little bit advanced travel demand models, we should be thinking about the all throughout the travel demand all throughout the day. The reason is, we need to, there are certain policies like peak spreading, that means we need to dissolve the peak load into the surrounding time segments, so that in the adjacent time segments, so that the overall network dependencies come down, requirement comes down, capacity requirement comes down. Also, there is lesser amount of congestion and so on. Lesser congestion means also lesser pollution. And then also we can assess policies like telecommuting or work from home. Like when people work from, given the option to work from home, they will stagger their trips. They may not want to go during the peak hour, they may go during the afternoon to the office for some time, and they may also change their habit of going to the office on certain days. They may not go to the office on certain days as well. So, this kind of policies actually requires us to understand adjustment of travel time in response to traffic congestion. That means, if the load reduces, what effect it will have on traffic congestion, accordingly travel time will reduce, and that will actually lead to other mode choices or other travel demand estimates. And we also need to understand that how this this travel time and this congestion and the linked travel times influences the shifting of time of departure to just beyond the peak period, or is it going to be a lot spread around a lot many hours. So, this peak spreading factors also needs to be determined. So, this could be based on traffic observations or household surveys to determine percentage of traffic shifting beyond peak hours. So, if you want to evaluate this kind of policies, we can go for stated preference surveys, asking people that, okay, will you shift your time if this kind of, suppose we introduce a toll or congestion price for a particular area during a peak hour or so on. So, this kind of peak spreading factors could be also included in our model. So, then comes the time of day TOD. This TOD is not transit oriented development, this time of day choice model. That means, we also need to determine at which is the time of the day when we will choose to travel. And so, that is why diurnal distributions of travel demand, and we need to understand those distributions, and traffic management and pricing measures could be devised, which are designed to reduce congestion according to this distribution of travel demand, and that will help us to even spread the traffic even further. And not only that, on demand traffic services like shared mobility, delivery solutions, this depend on the overall daily demand, and the demand varies from time to time, and accordingly we have to create supply, or we have to create supply of vehicles, we have to create supply of delivery agents and so on. So, that means demand throughout the day actually helps us to determine the vehicular load that will be coming to the network or to the system, and that means that the overall daily demand at different time period needs to be known. So, a taxi company like Uber would probably like to know what is the spread of the demand all throughout the day, and accordingly it will make sure that it gets those partners, driving partners or drivers who will be supplying vehicles during that time periods. And TOD factors, time of day factors, based on traffic volume observations and from household travel survey data. This is from where we get the data, and usually we apply it, determine time of the day of the trip after the trip distribution. So, once we know that this person will go from zone A to zone B, then only we determine at which time of the day he will go, and according to the time of the day we will also determine the mode choice and so on. So, the departure location, departure choice as well as the mode choice. So, usually we use discrete choice models, multinomial logic models, where different time alternatives are the choice alternatives, and we say that which likely choice alternative a person will choose. So, that is a discrete choice model, and departure time choice model is also based on preferred arrival time. That means, I want to arrive at a particular location, I will decide on my departure time based on that. So, it is basically to model the preferred arrival time instead of the departure time. So, this kind of models are also being used. So, these are advanced ways of doing this travel demand forecasting. So, in addition to that, we can also have other kind of models like tour or tour based models, where tour or trip chains are a series of interlinked trips. That means, we not only look at one trip, that is from home to office or office to shopping or shopping to office back to office and so on. So, each one is individual trip, and we determine the mode choice for each of this trip. We determine the time of the day of that trip for each trip separately. So, that may lead to inconsistency. That means, I may get a solution for mode choice of car for my going from home to office, but while returning back my mode choice model shows it to be transit, which is not possible. So, this kind of inconsistencies may arise. So, that is where tour based models comes in, and tours are basically trip chains of interlinked trips, and this helps in considering constraints and dependencies for different trips within a tour. That means, mode choice and behavioral response to different policies could be also affected for the for example, I change the congestion only during morning peak hour, but it will affect my mode choice, which will affect all the other trip choices within that particular tour, or my home to office and back to home tour would be affected because of only a congestion pricing policy in the morning itself. So, that is why this constraint and dependencies help us to determine my mode choices or my travel demand in a much better way. So, that is why tour based models are more robust, and here in tour based models the unit of analysis is a tour and not a trip. So, what kind of the examples could be home to work, dropping a child at school, which is an escort trip, and this total becomes, it could be one tour and then returning back to home, or it could be full train full trip chain like home to office, office to shopping, shopping to home. So, this could be also considered as a tour, and this tour generation models could be again divided into work tours and not work tours, and we can also determine rates of this. That means, how many of these tours happen per day. In that way, we can also estimate the total number of tours that are generated for different kinds of household. And then we can also have sub tour generation models within a tour, like meeting trip from work. It could be a sub tour within a bigger tour, which is like from home to office to home. Within that, there is a sub tour from office to meeting and then back to office. Now, we can also say primary activity and intermediate stop destination choice models could be also developed. For example, to determine which is the primary activity, which is the intermediate choice. For example, work is my primary activity and going to shopping is the intermediate stop destination. So, this kind of choice model also could be developed, and then tours, sub tours, intermediate stop mode choices. So, mode choice models could be also developed for each of these tours or sub tours or intermediate stop choices. time of the day choice models could be developed, escort trip models could be developed, right, for which segment of the trip it would be as escort trip, that means I will be accompanying my child to school and so on. So, usually these tour based models are much complicated than normal trip based models, where for individual trip it is very simple to predict its distribution, predict its time of the day, predict the actual mode chosen. But whereas in tour based model we have to be aware of the entire trip chain, and we need to understand several constraints and rules that what is allowed and what is not. So, it is not like each tour is, or each segment of the tour is independently thought of. It is a conditional decision. That means my decision to use a car depends on not only my one trip, but also on all the different trips, and my decision to use car in one trip is dependent on decision to car use on another trip which is already there. So, already linked. That means my decision to use car will be based on all the trips that are there. It is not only based on one trip. So, that is why we use lot of heuristics and rules for developing this kind of models, and we sometimes use nested logic models where we use conditional probabilities. So, when we do nested logic models in the mode choice model lecture, you will see that how to develop these conditional probability models, where we can link several decisions which are one linked with another, and together we can estimate the choices made during each of these decisions. Next come activity based models. As I was explaining, over in the image you can see, like in a trip based model we have home to work, then walk to school, shopping to home, and then from home again to dining, and from dining to again home. So, these are all separate trips. We need to have models for each of these different kinds of trips. Means we need to determine the trip rates for home to work trips, we need to determine the distribution, we need to determine the mode choice, but we have to determine this for every trip. Whereas in a tour based model, you see this home to work and work to shopping, and this then shopping to home, this entire thing is one tour. So, all these decisions are joint decisions or linked decisions. That means, decision to choose a mode from home to work is dependent on work to shop, and then from shop to home, and so on. So, these are all linked decisions. So, this is one tour, and then similarly we have home to dining and then back to home, this is another tour. So, instead of so many trips, we need to model for two separate tours in a particular day. Whereas, in an activity based model, we need to understand that the entire schedule for my day or the activity pattern for my day, like from home to office, then going to shopping, then coming to home, then going to dining and then coming to home, this entire pattern is dependent on several constraints, several things are interconnected. My decisions are also connected with my family's decisions. So, it is a very complicated choice process, and it is a joint decision process that people undertake. So, this entire schedule could be also modeled at, and there also we can use several rule based heuristics based way of deciding, and or it could be based on some nested logic models as well. So, this kind of decision making is called activity based models. So, it is based on the entire day's activity. So, it is similar to tour based models, but activities of an individual may include several tours, and these models are implemented using a synthetic population and a micro simulation framework. So, we have already talked about micro simulation, and we have already talked about synthetic population generation. So, for each individual we need to understand that what kind of family structure he belongs to, and then we need to determine his schedule for the entire day based on observed values from travel diaries of these individuals, what they have done, and then we can understand that this kind of individual belonging to this kind of socioeconomic background, having this kind of family structure, usually undertakes this kind of decisions, and that would be for each stage, like does he have a child or not. Based on that we have a probability. Then if I have a child, then does he goes to school, then we have a probability, and then if he goes to school, then should I take him to school, what time of day, which is the destination. All these decisions are linked, and together this entire decision chain is modeled and then we determine that okay, what is the activity of a particular day. So, in this way we develop that, and this becomes, as you can understand, the more it becomes very computationally intensive, plus the more number of things we connect in a decision making process, we need to have lots and lots of data supporting that. So, the data requirement for a trip based model to tour based model increases by quite a number of times, and from tour to schedule it increases further. So, that means the data requirement for this kind of models are very high, but at the same time these models are very policy sensitive, these models are behavioral based. So, that means you will get more accurate representation of the travel demand when you use a activity based model compared to a tour based model, and tour based models gives better results compared to a trip based model. So, activity travel patterns are simulated for each synthetic person, and individual activity travel records are similar to travel surveys. And once we do that, once we can estimate the activity pattern, we do static network assignment. We assign those movements into the network, and we get representation of different time period from the network, and we can estimate that a continuous representation of activity engagement pattern for a particular individual. So, in activity based models, we have got activity generation model, we have got escort activity models, we have activity duration model, how long each of these activities last. Then we have a work and school activity schedule models. We have destination choice models, which are constraint models. Destination choice is based on time of the day, or we have mode choice models, which are again constraint model based on the activity, based on the destination, based on the time of the day we do a mode choice. Then interdependencies in activity travel choices across household members, these are also considered. So, then coming to trip generation. So, looking at very basic trip generations that happens, number of trips that will usually in the trip based models, we determine the total number of trips that will begin and end at each TAZ or traffic analysis zone. For a typical work day or a weekend, we will have different travel patterns. So, we develop this model separately for a work day and separately for weekend, and these models are developed and calibrated based on data collected from the base year. That means, we will collect data and then either we use develop some models, then we have to calibrate those models, and we have to estimate that coefficients of the different variables that we have used, and so on. So, in this trip generation model, dependent variable could be either the trip rate or it could be the total number of trips. So, trip rate could be based on household sizes or different types of households, or it could be based on certain kinds of land use, whereas number of trip is based on aggregate measure for a particular zone. So many number of trips would be generated. Independent variables which determine the total amount of trips generated from a particular zone or a household depends on land use characteristics, zonal characteristics, socioeconomic characteristics of the household, and so on. So, these are the different things which influences trip generation. And we can have both zone based or household based models, as I just discussed. So, in zone based trip estimates, which are called aggregate models, these are conducted for different trip purpose. So, that means we divide the trips into for different purposes like work trip, school trip, business trip, and recreational trip, and so on. And for each of these trips, we determine how many trips are generated for each zone. And then when we do get that, these are calibrated on a this kind of models are calibrated on a zonal basis, and this results in loss of information of interzonal variability and overall model accuracy, because as you can understand, one zone have got different kinds of households and all, each has got different kinds of each kind of household produces different trip rates and all. So, when we do it on a zonal basis, so obviously the accuracy level of the model falls down, but at the same time it is easier to evaluate, and sometimes policy analysis also is easier because we can form some form of regression models. Whereas in disaggregate or household based models, these are also widely used, and this is where trip rates for different trip purposes are estimated for households of similar characteristics. That means we categorize household under certain socioeconomic groups and then determine these trip rates for different trip purposes for each of these household types, and then we multiply these trip rates with the total number of households, and then we can arrive at the zonal totals for number of trips generated for this particular zone. And future land use and household type forecast are required to determine this kind of models. So that means based on different kinds of households, number of households in this particular zone, and the total land use, which actually may be telling us what kind of commercial area, what kind of residential area is there, we can determine how many households or how many other trip generators are there, and that actually leads to total estimates of trips that are originating from a particular zone. So this gives us an example of different kinds of trips purposes that one can consider. It could be home based walk trip, that could be further divided into walk for business purpose, which is for service sector, then walk for commercial purpose, people going to walk in retail and shops, walk for industrial sector and so on. Then it could be home based school trips, home based shopping trips, home based other kinds of trips like for example medical trips, for dining, restaurant going trips, accompanying someone, taking someone to school or something, then other free purposes, sightseeing trips and so on. And home based business trips could be people who work from home or they do their own business. For them there could be delivery trips or repair trips or agricultural, forestry or fishery walk trips or other business purpose trips. And similarly, non-home based trips could be non-home based meetings that happens when you go to an office, or it could be return trips like people coming back from work or school, or it could be go back to home from any other particular other kinds of trips. So travel behavior of individuals depends on trip purposes, and while walk trips and school trips are regular, recreational trips are not. So that means maybe the travel time for walk and school trips are fixed, whereas recreational trips travel times could be changed. That means those trips are more flexible, and trips are classified as home based and non-home based trips that we already discussed right now, and sometimes return home trips are estimated from home based trips. That means if I can estimate all these particular trips, then automatically I'd be able to understand how many number of these trips, because anybody goes out from home will always return back to home. So from an estimate of all these home based trips, and we can estimate number of trips returning back to home as well. So usually many people do estimate only this part and also non-home based trip, but they ignore this part. They will just take a multiplication of this and then consider that, because peak hour is usually more the total load during peak hour is usually more during morning peak hours, and the evening peak hours are usually spread out. But again, that has to be investigated, or it could be different for different cities. So trip production and attraction, this is what needs to be determined when this kind of models actually talk about number of trips that begin and end at each TSZ, and it could be classified as trip origin and destination, or it could be classified as production and attraction. So the reason why we have these two classification is because the first classification, trip origin and destination, is sometimes we use it when we develop our travel matrices, like where the trip originates, where it ends, but it is not clear because sometimes the trip origins, like a residential zone, becomes a destination when the person is returning back home. So instead, to use production and attraction as the way to say how many trips are produced from a zone, how many trips are attracted from a zone. So this gives a more clear definition. So trip productions are based on residential land use, residential population, particularly for home based trips, whereas trip attractions are based on non-residential land use and intensity of activities both for home based and non-home based trips. So we can understand trip production happens like residential land use, residential for home based trips, that means these are the trips generated from a residential area that is being estimated. But if it is a non-residential area, trips are also produced there, because lot of meeting trips happens where in a business district. So those are the trips also that are being produced. And in case of trip attractions, it is primarily number of trips attracted both for residences as well as both for non-residences. But as we can understand, trips attracted for residences could be people coming to visit you, we are not usually considering the return home trips, because that is just a opposite of when people make a trip, they will obviously return. So, we are not talking about that. We are saying that number of trips attracted to your house, because some guests may come to your house and all. So, that is a home based trip that also leads to this total number of residential population also leads to some home based trips which are attracted. So, trip production and attraction forecast are usually done using different models or different ways. One is a growth factor model, where we use a linear function of explanatory variables to determine what kind of growth will happen for a particular production and attraction for a particular zone, number of how this will increase, or it could be based on a growth factor approach, where it could be depended on certain explanatory variables, that this is the amount of growth that is contributed by that variable, and we can also adopt that kind of strategy to determine what kind of growth will happen. Or the more popular approach is to have a regression model. It could be a linear or a non-linear regression model to determine what sort of explanatory variables play a role in determining the growth of an area. And we can, if we have this relationship, when the explanatory variables change, like for example, total area for residential land use change, automatically the number of trips will also increase, or the number of people living in a area changes, automatically the number of trips, home based trips will also change. So, regression models are the ones which are primarily used, and it will be taken up in the next lectures, in the subsequent lectures. So, this is an example of trip rate analysis, where average trip production and attraction rates for important trip generators are listed. For example, production rates could be done by residential land use, whereas attraction rates could be done by non-residential land uses, and trip rates are either expressed as percent trips per 1000 square feet of land use, or trip attracted per employee for non-residential land use, and per student enrolled in educational institutes. So, it could be trip rates could be expressed like based on the percent trips per 1000 square feet of land use. This is for trip production maybe, and whereas trip attracted per employee, this is for determining number of trips attracted to an area, depends on number of employees who are employed in that area. And if there is an institution and all, it could be based on number of students enrolled in that particular educational institution, because that will give us an understanding how many trips will be attracted to that particular zone. So, in these two tables you can see that for different land use categories like residential, commercial, retail and so on, these are the total for a particular zone. These are the total thousands of square footage that is there for this kind of particular land use, and we can also get the total number of percent trips originating from this particular land uses, and that gives us the total trips per 1000 square trips per 1000 square feet, and this gives me the trips rate. That means, for each 1000 square feet, how many trips would be generated for residential land uses. So, these are the 2.4 is per 1000 square feet, this is the number of trips that are generated, whereas for retail 8.1 number of trips are generated, for wholesale 1.2 number of trips are generated, and so on. Whereas for when we are talking about trip attraction, this is based on percent trip estimates. So, here we see that there is non-retail employees, and then there is retail employees. Based on that, in the CBD area, in the shopping center and others, we see that per employee 1.7 home based walk trips are attracted, or for home based around 4, in case of retail, home based around 4 shopping trips are attracted, whereas for non-retail, that could be like any kind of commercial, that means 1.7 walk trips are attracted per employee. So, that means this is how we can also develop trip attraction rates for a particular zone. So, if there is a university, that means home based school trips 0.9 home based school trips are attracted per number of student employed in that university. And here we can see the other rates like trips per household 0.3 non home based and For other non-home based, for non-retail it is 0.4. That means these are non-home based trips that are generated, attracted, and number of meeting trips probably attracted to this particular land use for this particular zone. Based on the number of employees. So, these are the different ways we can the trip rates could be ascertained either based on land use, either based on number of employees in a zone, and from that we can also estimate the total number of trips generated in a particular zone. And then comes to cross classification analysis, where we actually see that this could be done based on area or zone based, this could be classified as area or zone based disaggregate models. So, households are classified as per different socioeconomic characteristics like household size, household income, automobile ownership, and different households will have different trip rates. So, that means that how many trips are produced, and this trip rates again could be of different types. And this could be done. We do travel diary surveys. We have already learned how to do travel diary surveys, and from that travel diary surveys of the entire household, we can determine what sort of trips they undertake, and then we can average it out or aggregate it over the zone for a similar group of families, and we can arrive at the trip rates for that particular family. But this is called cross classification, because we are similar how we did those when we determined total, we were doing those simulation or micro simulation, or we are trying to determine the synthetic population. We have seen that we have divided the entire population into different groups, and then we are trying to determine how each of these groups will change. And similarly over here we will have different groups, and when the number of people in those groups change, automatically the total number of trips will change, because we will multiply this total number of people in that group by their trip rates. So, this is how we can estimate existing trip rate, total number of trips from a zone, and in future trips from that particular zone. So, trip rates are estimated from household travel diaries. The rates are assumed to be stable over a certain period of time. So, we need to do those surveys at a certain intervals, and too many categories actually may result in inconsistency in the estimated trip rate. So, as you can understand, if we have surveyed 100 people in a particular zone and we have around 20 categories. So, we roughly have around 5 households in each category. So, we may not get very good estimates. So, the more the categories, more the estimate robustness actually reduces. So, either we can increase the sample size or we can reduce the number of categories. So, here in that particular this example, you can see total home based non-work trip rates, and this is non-work trip rate and this is home based. So, in first of all we have categorized as per the area type, which is urban high density area, and then there is suburban area, and then there is rural area, which is low density. And then based on the first categorize the household as per the number of vehicles it owns, because number of vehicles determines the trip rates. These are explanatory variables, and then based on the number of persons in that households. So, this is a single family household, this is a 2.3 member family, this is some 2 members plus a kid, or some families may have a kid, some families may not have a kid. Then this is a 4 member family, then this is a 5+ member family. So, here we can see the trip rates for this particular group, which is a single member household with 0 vehicles, this is the trip rate. And similarly, for a 5+ member household and 0 vehicles, this is the trip rate. For a person having 1 car, the trip rate increases. For a household having 1 car, for this 5+ member household, trip rate increases, and for 2 cars it increases further. So, in this way we can determine the trip rates of different kinds of families, and accordingly we can determine the final total number of trips that are generated from a particular zone. So, this is another example where this you can see in this side the total size of the urban area is being taken, and then this is the average for that particular urban area. If I don't and then we have taken divided families as per their income into 3 categories, and their average could also be taken, and then for average these are the trip rates. Whereas for this particular income group, we see that if there is only a single member household, then for income group of 20, $1,000 lesser than that, the trip rate is 3.6. If the income rate increases, his trips increase. If income rate is more than 40,000, number of trips made by him is 4.5, and the average for this particular group is 3.7. The average on this side is 6. That means for all households having income of $20,000, this is the average trip. So in both ways we can read it, interpret these tables, and over here this basically means a household of 5+ size having lesser than 20,000 income does around 13.8 average number of trips. So in this way we can interpret the entire table, and this is a cross classification table. So these are some of the references you can study. So to conclude, the purpose of trip generation is to predict target year trip ends, which could be both zone based or individual based. Zone based estimates can be both aggregate or disaggregate measures, and disaggregate measures are more accurate since they incorporate the variability in trip rates due to variation in socioeconomic characteristics of the target population. And finally, trip production and attraction models should be developed for different trip purposes. And we have studied two ways to develop this kind of models. We would study the regression method in the next lecture. Thank you.